Hey Intro to Cal, here we go. Chapter 7, Linear Systems and Matrices. We're going to start off with Chapter 7.1, Solving Systems of Equations. So the objectives for this lesson are to use the methods of substitution and graphing to solve systems of equations in two variables. And then in another video, we're going to learn how to solve systems of equations to model and solve real-life problems. So today we're going to look at substitution and graphing. We're going to start with two equations. So to solve such problems, you need to find solutions of the system of equations. So you've got two equations, so it's a system. In the first equation, we have 2x plus y equals 5. And in the second equation, we have 3x minus 2y equals 4. Please don't feel like you have to write everything down. But if I talk too fast and you need to write something down, just hit the pause button. So here are those two equations again. We're going to figure out if an ordered pair is in fact a solution to these two equations. So what is a solution? A solution is an ordered pair that satisfies each equation in the system. Finding the set of all such solutions is called solving the system of equations. For instance, the ordered pair 2, 1 is a solution to the system, so let's see why. So you take your ordered pair 2, 1 and you substitute it in. 2 is your x and 1 is your y. So we have in equation 1, 2x plus y equals 5. So you get 4 plus 1 equals 5. And that's right. So 2, 1 is a solution to equation 1. Let's see if it's a solution to equation 2. So 3x minus 2y. Does that equal 4? So you get 6 minus 2. Yep, that's 4. So it's a solution. So because 2, 1 is a solution to both equation 1 and 2, it's a solution to the system. Solution of the system. Alright, so the first method for actually figuring out our solutions is going to be substitution. So there are a lot of steps on this slide. There are actually 5 of them. So don't feel like you have to write them all down. I'm going to do an example, so hopefully you can just follow the example. The second method is graphing. So you'll determine the solution to the system at the point of intersection. So you graph your first line, graph your second line, and where they intersect is the solution. So the 4 steps below go through those steps, but it talks about how to do it on a graphing calculator. We know how to graph, so we don't need to use our graphing calculator. Let's try substitution first. Here we have two equations. We've got equation 1, which is x plus y equals 4, and we have equation 2, which is x minus y equals 2. It doesn't matter which equation you start with. So let's start with equation 1. It doesn't matter which variable you solve for. So let's solve for x. So to solve for x, we need to move y to the other side, and we're going to do that by subtraction. So x equals 4 minus y. Once you have a single variable set equal to something else, you can substitute it into the equation you didn't use. So my second equation is x minus y equals 2. So I'm going to substitute my x in. So instead of writing down an x, I have 4 minus y, because I made that my x, and then the rest of the equation is minus y equals 2. Combine like terms, so 4 minus 2y equals 2. Now we're going to solve for y. So I'm going to subtract 4 from both sides. I get negative 2y equals negative 2. Divide both sides by negative 2 and you get y equals 1. Once you have your y value, you can get your x. So let's grab another color. Everyone loves pink. So put the y in your start equation, the one you started off with. So I have x plus y, which I found was 1, equals 4. So solve for x now. Subtract 1 from both sides, so x equals 3. So your solution is the ordered pair 3, 1. So that's how substitution works. Do a quick check, put it in equation 1, 3 plus 1 equals 4. Awesome, it's a solution. We're going to use the same two equations and solve for the solution, which we saw was 3, 1, by graphing. So in order to graph a linear function, you want it in y equals mx plus b form, or you can use slope-intercept. Let's just do y equals mx plus b to remind ourselves of how that works. So you put both equations in that form. So you want to get y by itself. So you subtract x from both sides. So this is your first equation. Your second equation is a little trickier because you've got that negative y. So let's move that to this side to make it positive, and we'll subtract 2 from both sides. So we get y equals x minus 2 as your second equation. All right, so let's graph. See if I can pull a line in here. So this is nice and straight. Do black. All right, so there is our y-axis and our x-axis. All right, so first equation. Your slope is -1, and your y-intercept is 4. So y-intercept of 4, remember, means 0, 4. So you go up, 1, 2, 3, 4. You get a negative slope, so down 1, over 1, down 1, over 1, down 1, over 1. There's equation 1, graphed. Equation 2, we'll do right here, has a slope of 1 and a y-intercept of -2. So that's the point 0, -2. So come down 2, and from here, we're going to go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. Let's throw that line in. And if you do a great job and it's super accurate, you're going to see that they intersect right here. What point is it? 3, 1. Who knew? So that is your solution, and that's how you find it with graphing. All right, so for your homework, you've got 3 problems. Your first one is to check for solutions. So is 0, -3 a solution for those 2 equations? The next one I want you to solve by substitution. If you look, these 2 problems are exactly the same, except one is by substitution and the other is by graphing. I want you to graph it without your graphing calculator. Your answers should be the same. All right, have fun. I'll see you tomorrow.